Welcome to Dana Point Harbor. This is one of the places that we like to bring students in order to learn about coastal formations and some of the processes that are involved in building coastlines. And it's an excellent place to do so. So if you kind of look out around here, what we're going to be doing is kind of going through the history, the geologic history, and telling a story of the formation of how this one particular coastline and harbor has actually been developed and constructed over millions of years. And then the whole point of that is taking this information. What we'll do is we'll do our hikes while we're in Scotland, and you can use the same information to look at similarities, differences, and be able to tell a little bit about the processes, so that hopefully that'll make a little bit more sense as we're doing our hike in Scotland.
Why do you suppose this area is called Dana Point? And the reason for that is because there was a person that actually wrote about it. His name was Richard Henry Dana. He wrote a book called 2 Years Before the Mast, which is sort of a story that follows his experience as a sailor on a boat where he came out to Dana Point.
As you get a view of this area, you see that we have a headland sticking out here. Due to the wave energy being focused in on the headlands, you're going to get the hitting of the headlands with a little bit more wave energy. That usually results in them being rockier areas, whereas a little less energy in the bays, and as a result they tend to be sandier, get little pocket beaches around there. The other thing that we want to focus in on from this bird's eye view is the harbor itself. Notice we have a very nice, calm harbor here. It wasn't always that way. This used to be the site of one of Southern California's largest surf breaks. It was something called Killer Dana, and it was a controversy when they decided to build this breakwater here. So again, this is a great opportunity to go back to your lectures, think a little bit about how coastal armoring is going to interrupt wave movement, sand movement, longshore current, and what is the result of putting in this breakwater here. The last thing that I want to focus in on is when you come into the harbor, you'll notice that there's this nice stair-stepped pattern that we get, and then on top of the cliffs we have all the houses built. That is what we call a marine terrace, which are very common in Southern California. And again, going back to your lectures, if you recall, that is a result basically of wave erosion on a wave cut platform, as well as sea level change through time. So these are going to be the most important things to kind of look at from this bird's eye view. And now what we'll do is we'll head down into the harbor and we'll look for specific features that we can describe one at a time. So now we're down here in the harbor itself, standing actually out on the pier, which gives you a good view of the entire harbor. You can see the Ocean Institute there, which many of you who have taken the aquarium science class are familiar with since we do one of our field trips there. But you also get a great perspective of the breakwater itself. Now that breakwater that we were looking at back from the viewing point at the top of the cliffs, here you can see how calm the water is as a result of that breakwater. Very little of the wave energy is allowed to refract within here. That makes this water very calm, which is perfect for keeping boats in here. It also means that very little erosion. You're going to get a lot more deposition. So here you have Baby Beach on the other side, which is a great place for families to bring their kids. This sediment was probably brought here by beach nourishment originally, that was artificially put in, but you can see that it's a nice calm beach, perfect place to bring kids. It's not going to get a lot of wave energy. You're not going to have much erosion here. Now from there, you can turn your attention up to the cliffs here and really just take a look how you have some kind of reddish rocks on the left-hand side. And then over here, you have more of kind of this tannish brown, whitish rocks on the other side. So this gives you a great perspective on how you can have two different types of geologic formations, both meeting at one particular spot. On one side, you have what's called the San Onofre breccia. Those inclusions, which are included in the rock, are very angular in nature. That's what defines a breccia. Now, if you have angular rocks, that means that those inclusions likely didn't erode down very much, and as a result, probably did not travel far from where they were originally eroded down. You can contrast this with conglomerates, which are also sedimentary type rocks with inclusions, but they tend to have more rounded and oval inclusions with them, largely because the inclusions eroded down as a result of traveling in waves or downstream beds or something else. And then that tells you a lot about how far those materials had traveled to get into the rock where they were originally formed. And then what happens is another type of rock forms sedimentary, and then those inclusions become locked within it. So keep that in mind as we then pan over towards what we call the Capistrano Formation.
You'll see two different types of rock. There's sandstone and there's shale. Sandstone indicates a beach type environment, and shale indicates seafloor, sort of a deeper ocean. So the layers are a record of sea level changes between beach and deeper ocean environment.
So we have two different rocks, both of them formed in different types of environments. Now, which one of them is likely going to be older? San Onofre breccia, you'll see that it's angled. We know that that had to have formed first due to what we call the position of original horizontality. So when rock formations originally form, they are always going to form horizontally. Then at some point, a fault line or some kind of movement can cause them to come up on an angle. Since we see that in this San Onofre breccia, but we do not see it, it's still perfectly horizontal within the Capistrano Formation, we know that at some point in the past, the San Onofre breccia formed, then due to some kind of geologic activity was tilted, and then at a time later, the Capistrano Formation formed, and that is still originally in its horizontal position, so it had to happen afterwards.
Up here on the left-hand side, you can see a restaurant, and below the restaurant, you can see where the two formations meet, there's a fault. And something happened here where there was a landslide, and what they did to address the problem was that they put bolts that were bored in about 100 feet into the rock that had drainage pipes to remove the water. And you might be wondering, well, why would you build a restaurant that was just above a fault? The California Geological Survey establishes criteria for faults that are active, potentially active, or inactive. Dana Cove Fault, which is what you're seeing underneath this restaurant, is classified as inactive.
Okay, so now we're over actually by Baby Beach. We've walked into where the bay is, and we wanted to stop here really to give you an idea of how this marine terrace goes upwards. We're all standing on the original wave cut platform. Then you have the cliff of the Capistrano Formation going up, and then you can see how there's homes and structures built right on top of that cliff. Now, this gives us a great opportunity to talk about the stability or actual relative instability of some of these cliffs and some of the dangers of building directly on top of the cliff itself. There's what's called the angle of repose, which is the maximum stable angle that particular formations can handle. And I believe it's like 33 degrees for the Capistrano Formation, where as much of this cliff around here is actually closer to 37, and in some places even much more than that, which means that there is a level of instability here. And a great example of that is if you pan right over towards where the old restrooms are that are behind the gate, and you'll notice there's a big rock to the left-hand side of that. That actually came down in a landslide after a rain, and it actually destroyed a lot of that restroom there, which is the reason why it's all gated off for now. So a great example of some of the dangers when we start to inhabit and develop and build on some of these coastal environments, keeping in mind that they're very dynamic systems and they are not static in time. They are always eroding back. You get erosion, you get deposition, depending on the marine processes that are happening there.
We walk a little bit further and you'll see a seam in the sedimentary material that's filled up. So there's a fracture. This is what we refer to as a clastic dike, and we see this in the Capistrano Formation. It looks like there's a fracture in the rock, and then it looks like it's filled in with sediments. How was it formed? Most likely an earthquake, and then liquefaction caused that sediment to fill in that crack.
Okay, now we've come to the front of the harbor, right out at the point that the breakwater starts from land. And what we want to bring you down here for is to really zoom in and get a feel for how the breccia actually formed. So this gives you a great perspective on that angle that we were talking about before. The fact that due to the position, the original horizontality, it's always going to form horizontally as all this material rains down. And you'll also notice that in some places there's much smaller inclusions, in others larger times. A lot of this has to do with how much energy is moving this material down. So we think that this probably was in the base of a submarine canyon where it originally formed. And that's due to a lot of the little marine microfossils that we've seen in there. In addition, if you notice, the inclusions themselves are a very different color than the matrix around the inclusions. This is a rock called the Catalina schist, and schist is actually a metamorphic rock. This was likely made up of a landmass that was probably offshore at some point, eroded down, and then became those inclusions that you see within the breccia. Now, what happened first? Well, the Catalina schist or the San Onofre breccia. Well, since the Catalina schist is inclusions within the breccia, we know that that had to have been formed first. I think the easy way to remember it is like a chocolate chip cookie. You got to make the chocolate chips before you form the cookie around them on the outside. Now what I want to do is walk a little bit over here. And the first thing to do is just notice that on this part of the headlands, you get a lot more wave energy. It's actually a relatively small wave day. However, you can see that there is a lot more wave energy than what we saw within the harbor. So just going back to our conversation about how the breakwater actually influences water movement and therefore sediment deposition. But what I want to turn our attention to is this little stump right offshore. There's always going to be an evolution with rocky and erosional environments. They often start off as headlands, but then as a result of wave energy being focused on those headlands, a lot of times you'll end up with a sea cave, which sometimes becomes a sea arch, and then many times will break down into a sea stack, and then in time that can erode down into a sea stump. So this is an excellent example of a sea stump. Now, if you look closely at that sea stump itself, you'll notice that it's more tannish brown. Even when wet, it looks much more similar to the Capistrano Formation than it does to the San Onofre breccia. And that is because right through here is where that inactive Dana-Conte fault line actually runs. So we have a different type of rock formation that the sea stump is made out of, erodes much more easily than the San Onofre breccia that we have on this side. Okay, and here we are at our final stop. We've come all the way from the point of the harbor past Baby Beach, and now we're along the road, and I want to focus in on these cliffs here, as well as this one big boulder that has eroded down and fallen down to the base of the cliffs. Now, the key of this boulder here that I really want to point out is if you come in, we're going to show you one of the inclusions for a fourth rock formation type. Here, you'll see what's called the Monterey Formation. Now, you may have heard about the Monterey Formation in one of your other oceanography classes. And the reason why is because the Monterey Formation is one of the primary oil formations. This is where a lot of our oil actually comes from. If you think back to past lectures, you'll know that Monterey Formation is formed up of a lot of things like diatoms. So just to put that in perspective, where we have a lot of oil is generally an indication of you have a shallow, really productive ocean with low oxygen at the base. So that way, if you have things like diatoms, they have a large amount of oil in them, a lot of fatty tissues that help them with their buoyancy. They start to sink down, die in huge numbers, and then they enter an area with very low oxygen. So they only get partially decomposed. That creates more of an ooze, which eventually, through high pressure, time, and heat, can form into petroleum. Now we come back here and we look at this, and the indication of that is you'll look at all these extremely fine lines. You'll notice they're going in this direction with this inclusion, this direction here. It's what we refer to as finely laminated. And what that is an indication that these were laid down with a very low oxygen environment. There's very little bioturbation as a result of having so little oxygen there, which is the perfect environment for the oil formation. Now, if you go offshore to some of our offshore rigs, this is actually the layer, the Monterey Formation that they're actually drilling into. In here, a lot of that petroleum has long since come out of it. So you're just looking at the remnants of the Monterey Formation. Now, how do we put this in context with the rest of our story? Well, we know that the Monterey Formation is an inclusion within the larger Capistrano Formation, this boulder, which is part of the cliffs behind us. So which one of them is going to be older? If it's an inclusion that was formed previously and then filled in with the matrix of the larger surrounding rock, this has to be older than the rock in general. So the best thing to do now, once you've viewed this entire video, is to kind of go back and then just think about it from the perspective of where we started, starting to put things in order about what did this area of what wasn't even a coastline at that point, what did it look like? And then through the ages, how did all these processes come together to come about to the modern Dana Point Harbor that we see today?
All right, good job, Rob, giving us all the information we need to know about our geological processes of here in Dana Point. Now we look forward to comparing it to in Scotland. And now go do the quiz.